All right, solve for theta in each of the following. So in this case, we're kind of back to the unit circle again, and we need to account for all of the places where sine theta is equal to a half. Okay, well, thinking of our unit circle, where is this the case? Well, really, we're wondering where the y value is a half, right? So right here, right at 30 degrees, that's root 3 over 2 comma 1/2, right? So that's where sine, right? That's where sine theta is equal to a half. So it's going to be happening at pi over 6, and then where else? Well, over here, right? That's going to be the same place that my y value is going to be equal to positive 1/2. Now you could do the cast rule and figure that out that way, but really you can figure it out from the unit circle as well. Okay, so that's going to be in those two places. Now, this just wants to know between 0 and 2 pi radians. So that's really just those two answers, right? So this will change when we have different restrictions on our domain, but for now, we just say this is where theta is equal to pi over 6 and 5 pi over 6. All right, B says cos theta is equal to negative 0.715. All right, so where would this be the case? Well, you can use cast rule again, but really, you know, where is my x value going to be negative? My cos value going to be negative? Well, it's going to be over here and over here. Okay, so that's a good place to start. Now, this isn't really something on the unit circle, so what I'm left with is I have to go theta is equal to cos negative 1, right? The inverse of cos of negative 0.715. Okay, and if you do that, you get 2.367, right? And I should say approximately, right? Because I had to round that. This is actually like an irrational number. So one thing you can do as well is actually just leave this, right? That is my full answer. That's as accurate as I could be. So this, especially if you're using my open math, it would understand that. So you can write it in there just like that, okay? But this isn't actually our answer, right? This isn't our answer because what did we just find? Remember what your calculator does. When I put in cos negative 1, your calculator starts from the positive x-axis and then goes from there, right? So that's the angle I just found in radians, right? That's 2.367, which kind of makes sense, right? 3.14 would be 180, right? So I'm kind of in the right ballpark. Now, okay, good enough, right? I know that angle, but I don't know this angle yet. Okay, so how can I do that? Well, to do that, I need to figure out what the reference angle is here. I got to figure out what this angle is, right? Because then if I know this one, then I can add that to pi and to figure out that second one. Okay, so how am I going to do that? Well, I'm going to go pi minus, and you know what? Why don't we just write it in like that? We'll write it in as cos negative 1 of negative 0.715, right? That's a perfectly accurate number. And what do we get there? Well, again, you could actually just leave it like this, right? Because that, again, that's as accurate as I could be. That'd be your perfectly accurate answer. But let's approximate that to 0.774, right? I'll leave 3 decimals again. Okay, so that's what my reference angle is, right? So now what I got to do is I need to add that to 180 to figure out my next, or to pi rather. So I'll say pi plus 0.774. So we get 3.916. Okay, so let's recap. So we have two angles, right? You got that one, and we've got this one, right? So now we just need a general way of saying that. So for the general solution, we'll say, and the problem here is that we actually have to like write them both out, right? So we have to say, okay, let's just do this first one, right? That first angle. So that was this. So we'd say that the angle was, so it would be theta, is equal to And again, you can write it either way. You can write that, or you can write the rounded version. Let's do the rounded version to keep things simple. 2.367, and then it would be plus 2 pi n, or sometimes you'll see it like 2n pi, either way, where n is a member of the integers. So now the integers, remember, can be negative numbers, right? So there are countable numbers and they can be negative. So what that would do, if I had like a negative n value, then that would kind of just change this to like a subtraction, right? Now what are we doing there? Well, when I add 2 pi n, what we're doing is we're starting from here, and then another 2 pi would be going all the way around again, and then going all the way around again, and then going all the way around again, right? So that's what's happening every one of those. Okay, now let's just change it up and do the next one. So now the next one, we'd say, so that'd be like theta 1. Theta 2 would be, okay, so that was this angle, right? 3.916. So 3.916, and then it would also be plus all the way around 2 pi n, where n is a member of the integers. All right, now this one has restrictions. So with the restrictions, it won't look like the general solution, the last one, right? I'm going to have like, 2 or 3 or 4 different answers that'll work with that. So let's see. So we've got secant theta is equal to -2. All right, so secant would be the same thing as, well, that'd be like, so 2 over 1, right? So then I could say, well, cos, right? The reciprocal there would be -1 over 2. Hey, that's on the unit circle. Lucky. So where is cos equal to -1/2? All right, so cos is going to be negative over here and over here. All right, that's where my x's are negative. Okay, so that's going to be really in those two positions. So that's going to happen. So theta is going to happen at 2 pi over 3 and 4 pi over 3. All right, now let's look at this. So if this is 0 degrees, and then this would be pi, and then so you go around to pi, and then you go to 2 pi, and then you go around to 3 pi, and then 4 pi. Okay, so we have to figure out all the different angles that happens there. So let's stick with just the positive direction here first. So we did this one, right? We went to there, and then to there, and then now what we have to account for is going all the way around to 2 pi, and then plus another 2 pi over 3. So if you like there, what we can do is go, okay, 2 pi plus another 2 pi over 3. Okay, let's write this a little bit different. Instead of 2 pi, let's call that 6 pi over 3, right? So 6 pi over 3 plus 2 pi over 3 is going to be 8 pi over 3. Okay, so that's our next one. So that's going to be 8 pi over 3. Now, we can really do the same thing, right? So just keep this in mind. It was 6 pi over 3, right? That was 2 pi. Let's do the same thing, but now we'll add 4 pi over 3. We'll add that one again. Okay, so that's going to be 10 pi. 10 pi over 3. All right, there you go. So there's all of our positive angles. So now let's do the negative ones. Okay. Oop. All right, so now the negative ones, we're going this direction, right? We're going clockwise. So this angle from here to here would be negative 2 pi over 3. And this one would be negative 4 pi over 3. That's nice because that's just going to be kind of the same as the last one, but just with negatives, right? So in this case, this will be negative 2 pi over 3. And then negative 4 pi over 3. And then same thing, right? That you would just take this as negative 2 pi and then minus 2 pi over 3. So we end up getting negative 8 pi over 3 and then negative 10 pi over 3. And there you go. There's all of our angles. All right, last one. So, okay, so we'll rearrange this. What I'm going to do is I'm going to divide both sides by 2. 2. So we get sine squared theta is equal to a half. So now we're not looking where sine theta is equal to a half, because the next thing we want to do is I want to get rid of that squared. So I'm going to square root both sides. So this is the same thing as sine theta is equal to 1 over root 2. Now at first glance I'm not really sure where that is, but let's rationalize that. Okay, so that'd be the same thing as root 2 over 2. All right, I do know where that is, right? That's on the unit circle at 45 degrees, or pi over 4. Okay, so this would just be at, so angle would be at pi over 4. Okay, and then where is this going to be the case? Well, one little thing that I didn't do. When I took the square root of this, well, we really should have accounted for the positive and negative version. So we got positive and negative version here. So what that means is that's going to be the case, you know, at pi over 4 and really all of these quadrants. So we just need to account for all 4 of those. So it'd be pi over 4, it would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so sometimes solving trig equations requires us to factor some things first and use some trig identities to simplify. So remember, your trig identities are on your formula sheet. So I'll go through a few here as well. So, okay, let's go through this one. So for the domain 0 to 2 pi. All right, so tan squared theta, or x plus tan x is equal to 0. Let's factor out a tan. So we get tan x, and then this is tan x plus 1 is equal to 0. So, all right, we want to know where is tan 0 for this part. And for this one, well, I'll make a little equation. So we'll say, where is tan x equal to 0? Okay, well, it's equal to 0 when x is equal to 0, pi, or 2 pi. Where is tan x, I'll make my own little equation again, tan x plus 1 is equal to 0. So rearranging a little bit, where is tan x equal to negative 1? Okay, well that's going to happen when x is equal to 3 pi over 4 and 7 pi over 4. And if you want do a little demo of that, right? So where is it equal to negative 1? Well, that's going to be the case where we have, you know, both these numbers are the same, right? Our sine over our cos is equal to 1, right, for our tan. One's negative, one's positive. Okay, so it's going to happen there. This one wouldn't, right? That'd be positive 1. That'd be negative and negative. So then it would happen again over here. So 7 pi over 4. Okay, next one. So here, well, you know what? This looks like our standard type of a question where we've got something squared, and then an x, and then a constant on the end. We can just factor this, right? So this would be the same thing as writing cosecant plus 7, and then, cosecant x rather, and then cosecant x minus 2 is equal to 0. All right, so for this one, we'd say where is cosecant equal to negative 7? Okay, so this would be the same thing as saying where is sine, that was x, I keep forgetting to write x, where is sine x equal to negative 1 over 7? Okay, so from here, all we have left to do is just write x is equal to sine negative 1 of negative 1 over 7. And the reason why I'm doing that is because this isn't on my unit circle, right? That's all I can do at this point. Okay, now, make sure we know what we're looking at, especially when it's not on the unit circle. Sometimes it can get a little bit, confused. So if we're doing cast rule there, right? So where is sine x negative? Well, it's going to be negative here and here. Okay, so what did we just find? Well, if you put that in, you get approximately negative 0.143, right? And negative, you got a negative angle. Well, that actually kind of makes sense because what your calculator does is it starts at the positive x-axis and then goes down from there. So it's down 0.143 radians, right? So not much, just down a little bit. Okay, so that's that angle. So, okay, so what I'm going to do to figure out, let's say, this angle, do that one first maybe. Well, that would just be 2 pi minus, and then not the negative version, it's going to be just the positive 0.143. All right, this is going to give me an approximation here. Okay, so we get 6.14, let's see, 6.14. Which makes sense, that's almost 2 pi, right? So there's one of our answers. Put a box around that so I can remind myself. Now the other one is I want to figure out what the angle is from here to here. So that's going to be pi plus this number, right? So then we'll go, so pi plus 0. Here, I'm going to run out of room here. Sorry, guys. I'll write it down here. Pi plus 0.143. Okay, so we get 3.28. So just over pi. Okay, so those are the tougher ones because now this one will work out a little nicer. So this is saying where is cosecant x equal to positive 2? All right, so that'd be the same thing as saying where is sine x equal to a half. Okay, well that's going to be equal to a half at, or when x is pi over 6 and 5 pi over 6. Okay, and I know I didn't write my answer very well in the end here, but here, maybe we'll just fill these in. So x is equal to those, and then 6.14, and then 3.28. So in my open math, I probably should have left one more decimal on these just to make sure. This probably should mark it as right, but yeah, you might want to just put one more decimal in there to make sure that it's accurate enough. You also could have left it with the inverse part there. All right, carrying on. So another general solution one. So now, in this case, we have, cos squared theta minus 3 sine squared theta is equal to 1. So now, the problem right off the bat here is I'm dealing in terms of cos and sine, right? Like, I'd like that to either be, all cos or all sine. All right, so if you pull out your formula sheet and try to remind yourself of all these mess of equations on the right, we've got sine squared theta plus cos squared theta is equal to 1. Okay, well what that allows me to do is replace cos squared theta with 1 minus sine squared theta, right? Just rearranging that equation. Okay, and then minus 3 sine squared theta is equal to negative 1. All right, so that's helpful. So now we can combine these like terms. So this is 1 and then minus 4 sine squared theta is equal to negative 1. Okay, so we get negative 4 sine squared theta is equal to negative 2. So sine squared theta is equal to a half, right? Just dividing by negative 4. And then square root both sides, so sine theta would be equal to plus or minus 1 over root 2. Okay, so which would be the same thing as plus or minus root 2 over 2, which looks a bit more familiar, right? Okay, so where does that happen? Well, that would happen at pi over 4, right? And then there, and then there, and then there, right? All of the quadrants there, okay? So in general, what we could do is we could just say, why don't we do this? We'll say the angle is equal to pi over 4 plus, and then do you see from here, I would only have to go around pi over 2, right? 90 degrees, pi over 2. So I'd have to go around pi over 2 times n, where n is a member of the integers. Okay, so for the sake of time, I'm gonna move on. All right, so now we can solve problems as well where we have a coefficient with the angles. So like in this case, it's sine 2 theta, right, is equal to root 3 over 2. So a little process for solving these ones would be first to adjust the domain for multiple, or for the multiple angle. So what I mean by that is if the domain is theta has to be greater than or equal to 0 and less than or equal to 2 pi, then let's actually figure out what 2 times theta, right? What like this angle, what that domain would be, right? And this is just going to help me restrict, you know, what numbers I'm actually dealing with here. So we'd say 2 pi, right? Like the overall angle here, okay, has to be greater than or equal to 0 and less than or equal to, well, if the angle was 2 pi, then 2 times the angle would be 4 pi. All right, so you see how we're just kind of like multiplying it by, you know, whatever the coefficient there was, okay? So why that's helpful is because now that'll tell me, right? Well, if I write this out, this would be sine of 2 theta is equal to root 3 over 2. Now, what you can kind of do is just for a second, just picture this 2 theta as just like, you know, x, or just some variable, right? So where is sine x equal to root 3 over 2? Well, that's going to, and root 3 over 2 on the domain of 0 for 2 theta and less than 4 pi. So I'm really going to solve this question first and then deal with what theta is after. Okay, so this would be true, so 2 theta would be equal to, well, it would happen at pi over 3, it would happen at 2 pi over 3, 7 pi over 3, and 8 pi over 3. Okay, so that's all the places. So that gets me in that domain, right, for all of those. Now what we're going to do is we are going to divide the solutions for the multiple angle to get the solutions for the single angle. Okay, so yeah, so if we have this written out, let's write that one more time. 2 theta is equal to pi over 3, 2 pi over 3, 7 pi over 3, and 8 pi over 3. So what that just means is if I want to figure out what theta is, I just need to get rid of this 2. So you'd really divide everything by 2, which really just means it's going down in the denominator for each of these, right? It's like times 2, or divide by 2, divide by 2, divide by 2. So all of that would simplify to pi over 6, pi over 3 after you simplified it, 7 pi over 6, and then 4 pi over 3 after you simplified it. And there you go. So I am going to, well, let's do this one quick. This one will be easy. So the domain of this one, before we get going, well, looking at this, what this really means, right, is that x is greater than or equal to 0 and less than or equal to 2 pi. So our new domain of 1/2 x would be greater than or equal to 0 again still. But then for this one, this would just be less than or equal to pi, right? You multiplied it by a half in that case, right? Instead of 2 pi, it's just pi now. All right. So now we can say this angle, right? Just imagine that that's just like a big theta, right? 1/2 x would be equal to, and we're really just wondering where cosine of 1/2 x, or theta, is equal to negative root 2 over 2. So this is going to be at 3 pi over 4 and 7 pi over 4, right? But looking over here, 1/2 x, right, has to be between 0 and pi, so not this one. So it's just this 3 pi over 4. Okay, so now really if I want to get rid of this 2, I'm just going to multiply both sides by 2 here. So then x would be just 3 pi over 2. All All right, so looking at this one, right off the bat, what I think I'm going to do is I'm going to rearrange this a bit. This would be the same as tan of 3x is equal to 1 over root 3. And our domain for 3x would be, well, multiply this by 3 and this by 3. So this would be 0 still. And then less than or equal to 6 pi. Okay, so I really need to do that. Where is it 1 over 3 for 0 to 6 pi? So where is tan equal to 1 over root 3? Well, it'd be pi over 6, wouldn't it? Because that would be 1/2 divided by root 3 over 2, which would be 1 over root 3. So perfect. All right, so it's going to happen here, right, at pi over 4. Or pi over 6, sorry. Okay. And then you can see it would happen again down here, right, at 7 pi over 6. Okay, so let's start writing down our answers. So we've got 3x would be equal to pi over 6. And then 7 pi over 6. And then let's just think about what the next step here was, right? So then we go all the way around and then up to like another pi over 6, right? So all the way around is 2 pi, but why don't we call that 12 over 6, right? That 12 over 6 pi, that's a little easier to deal with. So 12 over 6 pi plus another pi over 6 is going to be 13 pi over 6. Okay, and then again, 12 pi over 6 plus 7 pi over 6. So we've got 19 pi over 6. Okay, so that gets me to that one, right, again. So now we're going around for the next time, right? So now we're around again. So now we're at not 2 pi, but 4 pi. So we'll just imagine this 2 pi now is 24 pi over 6. All right, so one more on top of that would be 25 pi over 6. Okay, and then if this is 24 pi and we're going to add another, 7 pi over 6 to get to the next one. So now we're going to be at 31 pi over 6. Okay, and I'm going to end there because one more time around would get me to 6 pi, right? And I'm done at that point. So there's my answers for 3x, and now we just need to divide everything by 3. This one's actually going to be kind of easy. Here, so let's do this and say divide by 3, because nothing really cancels. So we just get pi over 18, and then 7 pi over 18. You're going to see a pattern here. 13 pi over 18. 19 pi over 18. 25 pi over 18. And then 31 pi over 18. All right, so now the next one says, now write a general solution for that same question. Okay, so a general solution would be not having this restriction, right? So now, all right, so we'll say x is equal to, and then we'll say pi over 18, okay? And then we want to make some sort of rule for, like, as it's going around, but like how much is it going around? Now, it's a little bit easier to think in degrees sometimes, but we don't really need to. We could do this as well. Why don't we take 7 pi over 18 and subtract pi over 18, right? So if we add 7 pi over 18 minus pi over 18, okay, well, that's going to be 6 pi over 18, or pi over 3. Okay, cool. So that's what the difference is from there to there. Now we could do the same from here to here, and then I think we'd be pretty safe, like if it turns out to be pi over 3 again. So that would be 13 pi over 18 minus 7 pi over 18, which is 6 pi over 18, which is pi over 3. All right, so I think I got the gist here. This thing is going, I could start at pi over 18 and then add pi over 3 times n, where n is a member of the integers. Maybe I'll just back up there too, that you can see that this thing is going up by pi over 3, pi over 3 every time, right? And I'm assuming it would be the same in the other direction as well. So with the integers, if this was a negative number, then we'd be like subtracting, right?